In the last video, I asked you to download from CTAN and GitHub the package HPGL to PostScript PS. If we look at the package from CTAN, it's in zip format, so we unzip it, creates a directory, CD into it, HPGL2PS, and we see that there is a large number of files, but there is a make file. So if we do the make, we find out that there is an error in circle.c line 86. So let me correct that via circle.c. It's at 86G. It doesn't look right, does it? Oh, no, it is right. That's the fprintf, and it's an error message, so it should go to standard ERR. So let me write that. Let's do the make again. And we get a load. What's landscape draw? A bunch of stuff missing. Why is that? DXY-PS. Should be. I can't believe that something would come from there and not work. First time to find here, first time to find here. Doesn't make any sense, does it? Well, let's abandon that. But there is one thing that's in this distribution that's not in the other one, and that's the man page. There is a file here called HPGL2PS, and there's another one here, DXY. So I am going to copy that DXY to ps.man to the home directory to GitHub. And I'm going to copy let me see if what happens there. There's a make file there. So let me copy make file to /GitHub, but let's make it makefile.ctan, and I'll work with it. I'll show you what I'm going to do with it. Let's go to GitHub. And we've got everything that we need here. Let's do a make. And we get everything made. There's DXY to PS, and there is HPGL to PS. So let me move DXY to PS to my bin directory so that I don't have to go looking all over for it. So we're set up. Now I do want to go to, this is lesson 19, and I have a directory DXY to PS. And what is important here is I have some test files that I want to show you. And there I've labeled them DXY because they are DXY plot files. So we're good to go. So this lecture is going to be on the DXY-GL commands and their use. You can get a list of the DXY-GL commands from the Roland manual. So if you go to archive.org and search for Roland, R-O-L-A-N-D, space DXY, and there's some manuals for their printers, the DXY-880, 990, and then I think there's a 1200, 1300, or whatever. And those manuals have a chapter on the DXY-GL, and they also have the, what is it called, RD-GL, which is the HP plus some extra. But we're going to just concentrate on the DXY-L. First command we're going to look at is the one called home. And what that does is no matter where you are in the image that you're creating, you can move the pen back to the 0, position. It moves it with the pen in the up position so you don't get a line. And I can show you an example of that if I go here to, first of all, let me show you the command file. So if I vi mark, home.dxy, all I have is, I drew a circle. Let me put the H command, that sends it to home, and then we're going to draw a circle there to show where the home position is on the page. So I'll do a DXY to PS, home.dxy, and then I'm going to output that to home.ps. That creates the PostScript image of the commands that I have in home.dxy. Then I can look at that using events, home.ps, and you can see in the lower left-hand corner here, there's a small circle, and that's the home position. The dark area, the shaded area here, is outside the page. The page is this white rectangle, and I have it set for an A4 format, which is the letter size for the United States. The default is A3, which is, I think, equivalent to our 8.5 by 11, but I don't want to generate plots that large. So that's our first command. Second command we're going to learn is the move command, and it has the form of move to position XY. So it moves the pen to position XY. Pen is up, and the value of X can be from negative 16,383 to a positive 16,383, and that's like a 15-bit binary number with a sign bit. So it's not 2's complement, and it's just what they have in the firmware on the plotter. Now let's do an example with a move to position 300 by 300. By the way, these numbers are integers, and they're the equivalent of the step size, which is 0.05 millimeters for most stepper motor driven mechanisms. So this would give you what, 0.8 of a meter plus or minus. So it's over 1.5 meters that you could do if you had a device that would cover that. All right, so we have let me just do this. Look at I have a script here, run dxy.sh, and I just go through here and do dxy2.ps, which is in my bin directory. You saw me put it there. And then I did the home. We're going to do a move, draw. Each one of these is a file. Now, Vim highlighted the print here because that's a bash command, but not to worry about that. So the second file is the move. So I will look at that. So events to move.ps. And this shows us that the pin position is right here. And I drew a plus sign there. That's not what you get when you just move. It just moves from the home. I remove the home position. And this is 300 over and 300 up. And then if you start drawing there, everything's referenced from that current position. Next thing we want to do is the draw. To draw lines, you use the D command, and it has a form of D, and then you have X1, comma Y1. So from your current position, you will draw a line to the point X1, Y1 on your paper. And again, X1 and Y1 are integers, and they have this range from minus 16,383 to plus 16,383. Now, if you want to draw a polygon, then you can use the draw command with ordered pairs. So you start current position, you move to X1, Y1. Then from there you go to the next point, X2, Y2, and you go to X3, Y3, to as many points as you want, to the last point, XN, YN. Now those are pairs, so if you type this in wrong and you put an odd number in here, it'll do the pairs up to the last number, the odd man out, and then flag you with an error. So this draws the line to X1, Y1 from the current position, then to X2, Y2, then to Y3, X3, Y3, until you're done. So that's draw. So let's look at, oh, I didn't show you what the file looked like. Okay, vi draw.dxy. And here I moved to 300, 300. Now I'm going to draw from 300, 300 to 1300 in the X direction, 300 in Y, so that's the same Y value as I moved to, so it's a horizontal line. Then I'm going to keep X constant and move up in Y, so this is the right hand side of the rectangle. Then I stay at that height, but I move to the left horizontally to 300 in X, and then I move back to the home position 300, 300, or the position that I started from. See, I moved to 300, 300, and I ended up at 300, 300, so it's a closed figure. So if I look at it, draw.ps, there I get my rectangle. Okay, so this is home position here, moved up to 300, 300, then moved over here, then up, then back, and then down. With those commands, with the move command and the draw command, with only those two commands, you can draw anything you want. You'd have to write you'd have to do a lot of programming, or you can do it by hand. And that's what I've done for these demos, but it's not recommended. So in the next lecture, I'll show you how to write a program to do this. Okay, the next thing that you can do, we're interested in, is the line type. In the line type, when you draw a line, it can be solid or it can be dashed. And there are 11 types, and they're difficult to list, so I don't list them. I'm just going to show them to you. So we will do a vi line.dxy, and here the line command starts with an L, and we go from +5 down to -5 for the types of line. What I'm going to do is I'm going to move to the point. First line is going to be a horizontal line starting at 300 in X and up 100 in Y, and I'm going to draw from there 1800, so that's a line length of 1500 horizontally. Okay, stays at the same Y value, and it's going to be of type 5. Then I move up 200 on the left hand side and draw line type 4, then move up another 100, draw line 3, etc. So let's look at what that looks like. So if I look at the output line.ps, that's what it is. Now starting at the bottom, this is line type 5, which is looks like a long dash, a short dash, long dash, short, all the way across. This is line type 4, 3, which has a real long and a short. 4, 5, oh, excuse me, I need to count down. So this is 5, 4, I was doing that and then I reversed direction. So this goes 5, 4, 3, 2, 1, 0 is just a plain line. -1, you get a larger spacing. -2, -3, -4, -5. So those are 11 line types that you can use. So instead of just drawing a plain line between your current position and your destination, you can make one of these line types. Next command type is an axis. You want to draw an axis. What this does is you have 3 parameters, P, Q, and R. P is what axis do you want to draw? Do you want to draw the x-axis or the y-axis? If P is equal to 0, you draw the y-axis. That'll be an axis in the vertical direction. And P equal to 1 is for the x-axis. The way this works is the axis consists of a line with tick marks, and the way the program is set up to draw them is you start at the normally origin, so you'll set it at the starting point, and then you will go draw a line segment of length Q. If Q is positive, you go to the right. If Q is negative, you go to the left. You go that distance, draw a tick mark, then draw another segment going in the same direction, another tick mark, and you do this R times. So if you have you want to draw a line from 0 to 5 and have tick marks, then you set R equal to 5. And then whatever length of axis you want is determined by 5 times Q. All right, so I've got a VI axis.dxy, and I was drawing. Okay, I'm going to draw 4 axes. This one is a horizontal one, which goes what was the first slide? Oh, one is a horizontal. So this is a horizontal axis, 50 steps, or a line of length 50 times 0.05, and then you're going to do this 10 times, so this will be a length of 500 for the line. The next one is we're going to do a shorter length, half the length, but 3 times, so that'll be 750 lengths. So this will be a longer horizontal line. Then here I'm going to move up to this point, 300, 500, draw a horizontal line, then come back and draw a vertical axis. So if I do this, let me do DXY to PS axis dot DXY, I get a message that this has not been implemented yet. So if I go DXY to PS axis dot DXY output to A axis dot PS, I get the error messages, and then if I look at the output, page is blank. In the README file, it mentions that there's some of the commands that are not implemented, and this is one of them. So my job is to show you how to write that. It's not that difficult. I do not know why they didn't do it, but they didn't do it. Whoops. What did I do? You know what I did? I took away my slides. All right, next thing to do is to do a scale. Let's see, now I didn't, where is my, there's a print. Let's see, I don't show it. All right, my mistake. But I can just show you the file. So if I vi print.dxy, let's see, did I do it? Oh, no wonder. Sorry. If I vi print.dxy, this is when I did draw a circle for the origin. I'm going to move to 300, 300, and then I'm going to print the string A through Z all caps with a blank between P and Q. Okay. So if I events print.ps, look at the output, this is what I get. Here's the origin, move over 300, up 300, and it prints that. Now I think this is one case where on the commands, if you go look at the manual, it says this space between the command and the first argument is optional. But I think for the print, the blank makes a difference. So let's test it. How would you do this? Well, what I do is I do a 2 capital Y, go down here and do the print, and let's go back to the same position in X, but let's move up like 20. And let me remove this blank, and this will tell us whether there is a blank or not. So we do print.dxy, output print.ps, then the events, look at print.ps, and it's overlapped too much, so let's move up a little further. So go back to VI, and let's move up to 50. Once again, run DXY to PS, print.dxy, output to print.ps, this is PostScript, and then look at it again, print.ps. And so we can see that, yes, indeed, this bottom line was done with a blank between the P command and the first letter. The second one is no space, so there is a space there. For the other commands, it doesn't matter, but for this one, it does. So we learned something. It's not in the manual. Also, that's the default font. Next command is the scale. So you can change the size from 0, which is the smallest, to 127 times as large. The default value is 3, so the size of the print that you saw in the last slide is 3. This is the manual. Here it shows you, this is the page showing the axis command. Let me make it full scale here. Remember the format was X for the axis, P tells you which one, then Q is the length. Oh, it's a larger number. It's not 13,000, it's 32, so they went up another bit. And the repeat value, R, is 1 to this number, which that's going to get, that you could print the entire universe probably. Oh, that's funny. So I have an example of scale via scale.dxy, and what I did here is I took that same string. Let me take that space out of there. I draw it at scale 3, then I run it up to 15, and I move up 200 units, draw it again, then I move up another 200, and then I do the smallest scale, 0. So if I look at the output, scale.ps, I get the following. Here is default 3, that's the size there. This is scale factor of 15, and it looks like the font changes just a little bit. It's bolder. I guess the line width goes up as the figures get larger, and then the 0. I would have thought that 0 would have not drawn anything. That would have been my default if I'd designed the system, but it's a bit teensy weensy. Let's look at that. One of the things you can do with eFence is I can magnify this. Let's go to 400%, go down here, and yes indeed you can see it, but eFence doesn't do a very good job of pixelating it. It's too small, but it's there. So you can scale your characters, and that's with the command Q. I believe it was Q, wasn't it? Q? No, S. Q is the command to rotate the text. So if you want to rotate text, before you do the print, you do a Q and then an N, and the N can have a value of 0 through 3. If Q value is 0, then it's horizontal. If 1, then the text is rotated to 90 degrees, so it'll draw it from your current position moving up in Y. 2 is 180 degrees, so it'll take from the current position, do the text to the left, and it'll be rotated upside down. And then 3 is at 270 degrees. So let's what did I call it? Alpha? Yes. So here I'll do the first line horizontally, then I will go vertically to the left upside down, and then down 270 degrees. So events alpha dot ps, and I moved it way over in the middle of the page, but here is with the angle at 0. This is with angle 90. This is at 180, and this is at 270. So if you're doing graphs like we were going to do with the axis, X and Y axis, then we can label things. I can understand the vertical, up and down, and horizontal to the right. Don't know where you would label upside down unless it's something you're doing some drawing that's going to be rotated. Next command in the DXY list is a mark. And there are 15 symbols. A mark is a command is capital N. I believe you can do these lowercase. I haven't tried it. We'll just do it now that we're thinking about it. Say N, P, and P is 1 to 15, and it's a symbol centered at the current pin position. So I've done a VI mark.dxy. What I've done here is I start at 400. Ooh, that's going to overlap. Let's see these are. So let me do a 300, and I do a mark. I move to 300, 1500. That's up on the page in Y, and draw symbol 1, 2, 3, 4 by moving horizontally 100 units. By the way, if you look at the Roland manuals and everything, they show that it's one command per line, but the DXY to PS package will allow you multiple commands per line to save a lot of space. All right, let's look at what we get here. If I look at the output mark.ps, I get this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, there's 2 overlap there. I must have an error in my. Yes, I do. I didn't move over 100, so there we go. Let's DXY to PS mark.dxy mark.ps for the output. Warning, symbol number is 0. Don't know why we got that, because I did 1 through 15. So there's a minor problem in the program, and I will fix that. Events part.ps, excuse me, part.ps, and it looks like that. And this is not what I was expecting. If I look at the manual, let's go back to the Roland manual, and let's see where it is. That's there it is, mark, N for mark. And here, let's blow this up a little bit. Here are the marks. A mark of 1 is a little square with a vertical line in the middle, and the center of that, where the end of the vertical line is in the middle, is at the current cursor or pin position for the plot. And then there's a octagon, a diamond, plus an X, triangle, diamond, little arrow, X with a bar, a Z, a Y, a little small box with X's. There's a star, a Z, a vertical, and then looks like a Star of David. Those should be the marks, but it's not. I will fix that. And last but not least is hatching. Wait, that's not what I want. I did it again, didn't I? Hatching. Now the hatching command consists of a capital T followed by a number n, which is 0 or 3, and it says we're going to draw a rectangle. And there you have an option of hatching internally. There are 4 options. If you have a rectangle with, think of the rectangle as being a border, and then the internal area is being hatched where we're going to draw lines. 0, you get the rectangle, you get the border plus the hatching. If n is 1, you only get the hatching. And 2, you get the rectangle only, and then for some reason they decide that 3 is also a 0. Now, x and y is the horizontal and vertical lengths of the rectangle sides. So the lower left-hand corner of the rectangle is current pin position, and then you draw over x distance, up y distance, back x distance, and then down y. Now, if those are negative numbers, then, excuse me, if those are negative numbers, then the rectangle is going to be oriented differently. Now, on the hatching pattern, you can have the lines close together or separated, and D is the distance between the hatch lines in the step sizes that we've been using. And then T is the angle of the lines. If T is 1, then they're horizontal. If T is 2, this is a typo, 2 would give you 45-degree slant, which would be upward going right, going to the right. A 3 would give you 90 degrees. It'll be vertical hatch lines, and then excuse me, 4 would be 135 degrees, so they would be slanted upward left, right? Excuse me, I'm just, for some reason, dried out. Okay. So let's, where's hatching? Events, hatching.ps. And it's blank. The reason it's blank, it's not implemented. DXY to PS, hatching dot DXY, and it shows not implemented. Cross hatching rectangle.c is a routine. It's not implemented. Shouldn't be that difficult, so I will do it. So, and there's a couple of other commands for drawing. Did I do a circle? There's a circle. Let's see. Yes, I did a circle. Let me show you how the circle works. Didn't put it in my notes, but the circle command consists of the capital C, then the X and Y position of the center point, the radius, then the starting angle that you want to draw. If you want to draw an entire circle, you start at 0, which would be the right-hand edge, horizontal from the center point, and we'll go 300 from 0 to 360, and that would be drawing it counterclockwise, and I do it in 1 degree increments. This last number is supposed to allow you to draw hexagonals and octagons and whatever by not drawing every point on the circle, but just draw from one point. Say you draw from 0 to 45, then you would get a straight line, not a curved line on the circle. I'll get this working by the next lecture, but this thing doesn't work what was, so I draw one circle at 300, 1,000, then another one at 1,300, 1,000, and then a third one at 2,300. And what I've done there is I tried to get a diamond, and then here I start at 90 and go 270, so that'll give 3/4 of a circle. Then the others, I draw 3 circles all centered at the same point, radius 100, 200, and 300, starting from 90, which is the top of the circle, going around to the horizontal point on the right hand side in 1 degree increments. You can stop when you are watching this YouTube video, you can stop it and back up a little bit to compare the image with the commands. So if I look at this, event circle.ps, here's the one where I drew at this point, 300 and 1,000, whatever it is, entire circle. And this one I tried to go and just start at 0, go to 90. It should have been just one straight line, then to 180 straight line, then to 270 straight line, and then back to 360 straight line. But didn't work that way. The third circle here was to draw from 90 to 270, so that'll give you a half moon, a half arc. Then the last three circles I draw is at the same center point, but starting at 90 to 360, which will get you back to 0, and I had 3 diameters, 100, 200, and 300. So by a combination of a number of things, you can draw all kinds of circles. Let's see how I'm doing on time. 42 minutes. Let's stop the video. There was a lot to cover, and I haven't covered it all. There's some commands remaining that have to do with relative motion, and I'll have to get everything fixed. So that's rather interesting that this package is only available from C10, and it doesn't compile correctly, and it's available from GitHub, but not everything is implemented. And it's even worse than that. If I look at, we go back to GitHub, and let's look at the source code. Sorry, I need to do this. If I look at the more complex graphics commands, the HPGL or the RD-GL, if I look at HPGL.com.c, and if I go and look at all the commands, this procedure translates RD-GL, which is the Roland DG graphic language, into PostScript, and it's a superset of the HPGL. All right. If I go down here and look, you can see the things like advanced half page, not implemented. Automatic pen lift, not implemented. Arc relative, not implemented. Acceleration select, not implemented. Unknown HPL command. Alternate character set, not implemented. Chord angle, not implemented. So there's just a large number of stuff. I think more than half of it is not implemented. So I am going to just totally ignore that. If it's okay with you. Now, what I'm going to do, let me make this clean. this is where it starts out. I'm going to remove the HPGL commands, but I can't do it because the DXY to PS code depends on some of the libraries here, and I'm going to have to separate them out and make this into one neat package, and then when I get everything working, I will put it on GitHub for your perusal and use. Thank you for your time. I've got to get out of here, and I'll be back shortly. It shouldn't take me but a few days to get everything. I'll probably do it in one day, but let me not guarantee the date. Just spend some time looking at it and what would you do to get everything running. Thank you for your time. There was one more command and I forgot. It's a pen, and it consists, this allows you to change the width of the lines by using the capital J, and then you have 8 options, 0 through 8, and the pen size, and there's a default. If we look at the manual, actually we look at the code. Anyway, these things start from a small value like 0.0125 millimeters up to 1 millimeter or 2 millimeters. And what I do here is I draw horizontal lines that are 1,500 units long horizontally, starting with the smallest pin size up to the largest. Then I go up and I start at point 300, 1,500, and I draw a line at, what is this? Oh, this is 45 degrees. Then this is a slightly smaller angle and another one. And the purpose is to illustrate something. If I look at the results of these commands, we can see, let me magnify this a little bit so it's a little easier to see. The pin width starts small, and events doesn't exactly scale this right, but these are slightly larger, gets to a large value. And then this line right here is at the wrong width, because after I draw this line or issue the command, then I go up here and move up here to 300, 1,500 and draw these 3 lines, add a line width of 3 or whatever it was. This is the 45, then slightly less, and then almost, what is that, almost 30 degrees, whatever. And the purpose here is to show that for these lines, for lines at any angle, they are going to be smooth when they are drawn using PostScript display language. This will not happen if you're using a physical plotter, because the pen can only move in increments, steps in horizontal and vertical. In order to do a 45-degree angle, you have to move the X and the Y stepper motors simultaneously. And I'm not sure that all plotters can do this. So what happens is, for angles that are not horizontal or vertical and not 45 degrees, you're going to get jagged lines. And that's just the nature of the physical properties of pin movement with stepper motors. So I just wanted to add this important note here. And again, there is a bug here. So there are several bugs in the program. The program is like, what is it, almost 30 years old now. And evidently, you and I are the only ones that are interested in it. And we're going to fix it. Thank you again for your time. And I again, sorry to take so long, but let's get it done.